Welcome back, everybody. Today's topic 1.16 working with intermediate value theorem, the IVT. Today's notes is day 11. As always, this is Mr. Martha. And today we're going to be talking about the intermediate value theorem, which is one of the most important existence theorems that we'll study in calculus. And this is called, again, the intermediate value theorem. Like all existence theorems we will study, the IVT relies on the continuity of a function. And the theorem is stated right there. So the IVT, if f is continuous on the closed interval AB and k is any number between f of A and f of B, then there is at least one c in AB such that f of c is equal to k. All right. So what does this mean is if I have a continuous function as I have right here, right, as you guys see right there, and then if I'm looking for a number between A and B, right? A and B, which we can call C, right? So C. So if the function is continuous through those values, through A and B, then if there's a C, then the function itself went through some value f of C as well. All right. If the function is not continuous, then we cannot pretty much make that statement that this is automatically false if it's not continuous. All right, we'll see some examples where this is clearly shown. So on example 1, the function f of x is continuous on the interval from -3 to +9, with f of -3 being equal to 0 and f of 9 being equal to -12. Which of the following would be a correct statement concerning the existence of a value c by the intermediate value theorem for the function f of x? So what do you guys think here? What do you think would be the answer? So on A, if you look closely, right, 12 is not between -3 and +9, right? C is equal to 12 here. That's my C value. So automatically right there, we know this is false. All right. So we're looking for the one that makes it true, right? The only one that should be true. Now, if you look at B, -1, all right, so C equals -1, that is between -3 and +9. So that checks off, right? That's the first thing that should check off. The C value is between the interval and it is continuous. But if you notice, our highest value goes from 0 to the lowest one, which is -12 on F, right? So pretty much here, since -13 is it's outside that range, we cannot guarantee its existence, all right? We can guarantee any number between 0 and -12. But since -13 is pretty much right there on the left of -12, so it should be, so this one's also false. All right. Now, if you look at C, f of -2, so C equals -2. So that's again between -3 and +9. That checks off, right? And then for our f values, so f of -2 has to be between, right? Has to be between f of -3 and f of 9. So in this case, it is because I know f of -2, which is -10, is between. Actually, I put it backwards. Is between -12 and 0. So that one is true. And then the last one, so C is equal to 8. That is between -3 and +9. But then again, f of 8 is equal to +1, which is outside the range. So I hope this gives you guys a little bit clearer understanding of what the intermediate value theorem is right there. So now let's look at the next one. So it says use the intermediate value theorem to show that the polynomial function f of x is equal to x cubed plus 2x minus 1. So the first thing I should know is that have to determine whether f of x is continuous. And I know it is continuous because all cubic functions are continuous, and this happens to be a cubic function, right? It kind of looks something like that. So we know it has continuity. Checks out. And then they're giving me a closed interval between 0, 1. All right. And then they're asking me to see, right? It says when f of x has a 0 on the interval between 0 and 1. So I'm looking to see if f of x is ever equal to 0. I want to know if it crosses the x-axis between 0 and 1. Okay? So if I substitute f of 0, I'll find that 0 to the third power plus 2 times 0 minus 1. That gives me negative 1. And then f of 1 would be 1 cubed plus 2 times 1 minus 1, which would be 3 minus 1 is 2. All right, so 0 is between these two values. I can say, therefore, right, there is a 0 where there is a c value. There is a f of c where it's equal to 0. Again, mainly you can tell one of the main things is that when we use the theorem to evaluate this is that you look at, does it change signs? If it changes signs, it went through 0 automatically, all right? If it ever changes sign, if it went from -2 to +10, it had to go through 0 if you wanted to go down that path.